A very good evening, ladies and gentlemen. Welcome all of you to ISL. I am really happy to see you in this evening with another public lecture organized by Civil Engineering Sectional Committee. Well, I am Chatura Jayasinghe from the committee. Before we commence the event, let's pay tribute to our motherland. So please stand for the national anthem. Thank you, Iran. Ladies and gentlemen, I would like to welcome all of you formally for today's event, lecture, Engineering Challenges in Design and Construction of New Bridge over Kelanin River. On our invitation, we have here Dr. Haruka Shuhashi, the team leader, the engineer of ongoing national project, which is New Kelanin Bridge Construction Project. On behalf of the Chairman, Professor Ranjit Disanak and Civil Engineering Sectional Committee, I would like to warmly welcome you to the institution. Now it's my privilege to introduce today's presenter, Dr. Haruka Shuhashi. Dr. Haruka Shuhashi is currently engaged in the landmark project of Sri Lanka, New Bridge Construction over Kelanin River, as the team leader since 2015. He is an expert in long span bridges, including suspension bridges, cable stayed bridges, extradosed bridges, arc bridges, and concrete box girder bridges. He has involved in design and construction of the world's longest Akashi Kaikyo Bridge and Tatara Kurishima New Kashinas Nantan bridges. Also, He has many experience in design, construction and rehabilitation of bridges in many countries such as USA, Italy, Vietnam, South Korea and so on. He holds a PhD from Tokyo Institute of Technology on fatigue behavior of long-span suspension box type bridges. Further, he has submitted more than 150 technical papers and has published a translated book, History of Modern Suspension Bridge, Solving Dilemma Between Economy and Stiffness. He is also a member of several engineering committees in Japan and former member of PIARC. Ladies and gentlemen, please welcome to the stage Dr. Harukazu Hashi to deliver today's lecture titled Engineering Challenges in Design and Construction of New Bridge over Kelanin River.
Okay, good evening. Thank you very much for your kind introduction, and it is very honor for me to make a presentation in front of honorable guests from the government as well as industry and educational academy. My presentation is about the engineering challenges for the design and construction of new bridge construction over the Kelanin River Bridge. This includes a lot of, this contains a general aspect of the project as well as technical issues. Where is that? The outline is, first I would like to talk about the project outline and engineering features. Then second, design of Extradosed bridge. Third, soft ground treatment by power blender method. Fourth, temperature control of mass concrete. And at the end I will show you the progress status of construction. The first one is more like a general, but from the second 3/4 is more technical, and I'm really wondering that if those topics are too much, detailed and may not be easy to understand, but I try my best to make you understand. The project outline, I don't think I needed to explain in detail. It is it is about 5 kilometers north of Colombo Center. The bridge is crossing over the Kelanin River. So the introduction of the project, that the baseline and the port access road that our project locates has a heavily traffic with 86,000 or 27,000 vehicles, especially after the opening of the CK Colombo-Katunayake Expressway between the airport and the Colombo. So, so further, as you may know, that the port access elevated highway bridge, which connecting from our project to the port, is now implementing, and in addition that the extension from Orgadawata to Rajagiriya and then to the Battaramura, finally connecting to the OCH, is proposed. So with these, so this is the expressway network. That the pink one is our new Kelanin Bridge project, and the red one is already the expressway already in service, and the yellow one is under construction or under planning. So anyway, that our project located at the core of this connection point that becomes a node of this expressway. So this becomes a network when it is completed. There are two packages for this project. The blue one shows the package 1, which is mainly built for mainly the steel bridges. which construct over the existing bridges, existing road, over the baseline road as well as port access road. Whereas the red part, which is package 2, is parallel to the existing road connecting to the CKE. So it's diverting from the CKE endpoint and connecting. And in the middle there's a junction, the loop, that divert the traffic to the port as well as to the baseline. So this is package 1. It shows the number of piers. We have 70 steel piers and 28 concrete piers. As you see that, as I mentioned, that all the structures are built over the existing road, and those are made steel. The reason that we use for adapted steel is accelerated construction over this concrete structures. That because of the heavy traffic, that we have to minimize the impact of the traffic, existing traffic. The steel erection is very fast and less impact to the existing road traffic. Now, package 1 is awarded in 2017 December to the contractor JMT, standing for the JFE, Mitsui, and the Toda JV. And it's the construction period is 36 months, which contains steel fabrication of steel, erection of steel, as well as erection. For the package 2, that is, as I said, that it is parallel to the existing road, that is made of concrete, in the contrary. And at the center, you see that the Extradosed bridge, that is a cable-supported structure, which is to be built in this country for the first time. That on the right side is connecting to the CKE by the pre-stressed concrete, post-tensioned box girders. And on the left side, that is also made of steel concrete, pre-stressed concrete bridges. Those are all box girders. And this package is awarded to the SMCC Sanken JV. And the construction period is almost similar to the package 1, 2 months earlier than the package 1, from October 2017 until the 2020. And it contains construction of concrete bridges as well as soft ground treatment for bypass as well as connection parts. So before I go into the technical challenges, that I would like to mention about the other aspect of difficulties that especially the PMU or the RDA was tackling and successfully solved. Relocation of residential houses, which amounts 377, are inside the right-of-way, had to be relocated, and it's relocated to the Saramura housing area as well as self-relocation. Also, the Atomic Energy Board building, NITA building, is inside the junction area. That has to be also shifted, moved somewhere. Also, the high tension cable, overhead cables, and pylons, piers, towers are crossing over our project area. That is also a huge problem. But successfully, last month I think, that all the cables and overhead cables are removed. Atomic Energy Board building also now is also completed outside our project area. In addition, there are more difficulties. There are temples, business buildings that also impact the alignment of the project. Also, environmental sensitive areas in our project, vibration is also very important to tame in order not to impact to the residential areas. A, B, C, B, Sojitsu, all these buildings are also sensitive to the vibration. In addition, that there's a railway and petroleum pipelines crossing our project that also near to the foundation area, that requiring very careful construction of foundations. Finally, we have so much utilities CB high tension cables 220, 132, 11, water lines, telecom cables, sewage lines. All of these are underground, which we do not know where it is, although there are some sketches. So this is a huge amount of work we needed to locate where those utilities. We cannot, in the design phase that we located our foundation away from those major utility lines. However, that in the construction, the contractor has to excavate all the foundation area manually as a pilot excavation, and see that whether the utilities are not. And however, that there are many unknown utilities found and they had to be relocated, and it took a lot of time, not only for the contractor but the employer to asking the utility owners to shifting or move. And also that the protection of the utilities are always mandatory, not to damage the utility lines. Now going to the design. The design is, since it is built in this country, the primary standards for the road is the RDA standards. Also that the structural design, basically the Sri Lanka is using the British standard 5400. But those are not enough for designing the bridges, so therefore we use several Japanese standards which is more applicable, and also American standards. So it's a combined use of the different standards. But primarily that the BS 5400 was used. The design condition, just briefly talking about this project, that the design speed is 60 kilometers for the normal main line, but 40 kilometers to the ramp. Ramp means a connecting road. And the dead load, we have to consider, of course, dead load is the self-weight of the structure. Also the superimposed dead load, which is asphalt pavement, all these that loaded after the bridge is connected. Live load, we call it the live load, which is a vehicle loading, which composed of the uniform loading as well as the truck loading. Also, wind load is to be considered. In this country, that the basic wind speed is 33.5 meters per second and 10 meter average. Temperature changes. It depends on the concrete or steel that the temperature ranges differs. For the steel, 24 to 40 degrees, and for the concrete, 21 to 35. In addition, that we consider that in case of the future replacement or the breakage of the cable, that was also considered as a load. In addition, that the durability is very important for the maintenance period, that the concrete cover has to be sufficient amount of concrete covers so that the corrosion will be minimized. And also the painting that for the steel, that is also important for less maintenance. Drainage detail, deck waterproofing, and fatigue detail. Those are the especially that to be cared in the design. The design live load, if you're a civil engineer, you might know that there are two types of loading. HA loading, which is like a uniform distributed load, which is applied on the lane. But in addition, there is a HB loading. It is like a truck. It is not exactly the truck, but the motor like this, that the 4 axles, that so that truck is also loaded on the structures. So, okay, now finish the loads, and now I'm talking about the materials. Concrete, we have used up to 50 megapascal concrete, which is used for the PC, pre-stress post-tension girders, as well as pylons, where the forces are, stresses are higher. But the others, we use a 40 megapascal concrete. And for cement, that we use a fly ash contained, which is low heat and also long-term durability. We use the permanent fly ash contained cement. But we also use, we're going to use the OPC, ordinary Portland cement for the structure used for the superstructure. Rebar, grade 460, and the maximum diameter is 40 millimeters. Pre-stressing steel, which is, this is Japanese standard, 15.2 millimeters 7-wire strand. Stay cables, that is I'm going to discuss later, but it is a very high durable stay cable made of, protected by the epoxy. For the steel, used for the steel bridges, there are several kinds of steel, and the maximum thickness is 50 millimeters. The connection is we use high tension bolts. That is, and also let's see. And for the coating, as I said, that this is very high durable coating using the fluorescent paint, and also use hot dip galvanized for the miscellaneous structure. For steel structure, structural steel for steel bridges, these are the table shows that what is the strength level. The highest one, SBHS 500, is reaching up to 500. This is a quite high strength steel, and SBHS is a high performance steel because it has a high high resistance to fatigue, fracture, and also very good for the welding works. So this high performance steel was adapted for the first time in the Southeast Asian countries. Coating, there are coating used for the exterior, interior, or the joint, depending on the location that the coating system different. But the most exterior surface, which has to be protected from the weather, atmosphere, is, we call it C5 coating system, which is also again for the first time to be used in this country. It has at the mill shop, means for the plates, they have in organic zinc primer, but at the fabricator's shop, they have first in organic zinc paint, epoxy resin, and fluorine resin. Total amount of the thickness is 250 micrometers, which is 0.25 millimeters, which is quite thick. Now for the geotechnical, this I think you already know that this area that there are some weak soils, so to speak, the silt and also peat. That in this picture, that the green one and the yellow green one is peat, which is very soft and water content is high. So for the foundation, we are driving into the rock. But however, the rock has several degree of weathering 1, 2, 3, 4, and so anyway, we are penetrating into the rock at least 1D diameter of the pile, and to see the checking of the rock integrity. So the piles are all driven into the pile. So the length of the piles is depending on the site, but however it is in the order of 20 to 25 meters. So board pile is constructed to the depths. Now for the main bridge, this I will explain later, but the main bridge is Extradosed bridge building right next to the existing concrete bridge, spanning over the Kelanin River. Both foundations are located outside the river. This is PC pre-stressed post-tension box girder, and the box girder is to be erected by the scaffolding. The length of the box girders are ranging from about 165 to 260 meters, all the span 4 or 6 span continuous bridge. And the girder is made of units, one monocell or the two cells structures. depending on the width of the girder. This is for the steel structures. That steel usually span longer than the concrete. Here that we show that the red lines indicate the steel girders, and the multiple girders are connected to each other by the cross beam. And see, because of the width changes due to the connecting ramp, so that in order to accommodate the width, that the number of girders varies. This is also the same, that the girders are adding where the span is where the width is wider. In this case, the maximum span length is 78 meter. This is this is the largest span, longest span, and for the steel, this cannot be done. And this is a curved bridge. We have a lot of curved bridge because of the ramp, and also this is one of the sharpest curved bridge connecting between the main line. So this is a 2-span, and the span length is not symmetrical. Therefore, when the loading, dead load, self weight, as well as live load is loaded, the girder is trying to rotate toward the outside, and that creating some uplifting load, negative loading. So therefore, that we used a special bearing, as shown here, that the pin type bearing, which has more resistivity to the uplifting. This is how the girders are supported by the portal frame pier. This portal frame pier also made of steel and assembled at the site. After the portal frame is built at the site, the girder is sitting on the portal frame. And especially these portal frames are sitting on near the carriageway, that the bottom part of the column are covered by the concrete, also filled by the concrete, to protect from any vehicular collision. It is because that our structure is so close to the carriageway, maybe some driver might collide. So that's considered in the design. So the height is about 11 meters, and the width is 40 meters. So it's such a huge structure. The concrete deck, usually the deck is made of solely in the concrete, reinforced concrete. However, for this project, we use the steel concrete composite deck, which means a composite of steel plate and the concrete deck. So you see the right hand side, that is a steel part that is connected with how do you say? The concrete is cast here and bonded, and so the shear is taken by the shear stud as well as deformed sections. And this, by using this composite deck instead of the concrete deck, reinforced concrete deck, we can reduce the thickness of the deck 220, 240. Also the span, applicable span, can be longer. This steel structure is no use of the formwork, additional formwork, because this steel is used for the form as well as a permanent structure, and very strong for the cycle fatigue as well as the construction. For bearing, we are going to use a pot bearing, which is made of steel. Also, so instead of using the rubber bearing, which has used being in some bridges in this country, we use this steel bearing, which could higher resistivity to any deformations, and also for the corrosion protection, that we apply the aluminum magnesium metallizing on top of the bearing. That is a longer life durability. For expansion joint, again, many bridges use rubber type, but for the we are considering more about the durability and less maintenance. We use the finger type, which is made of steel. Now, this is the general. Now I'm going to a little more about the technical issues. The first is the design of the Extradosed bridge. I think this is mostly, many people are interested in this. So, what is the Extradosed bridge, or what is Extradosed? This bridge type is proposed by the French engineer in 1988, and the girder is suspended by the stay cables, but unlike cable-stayed bridge, some of the load is also carried by the girder's stiffness. So it's a combined of the PC girder and the cable-stayed bridge. You can see that the figures over there. That you can see that the concrete girder, which has thickness higher at the pier, that is normal pre-stressed concrete continuous girder. But if we span a long span, that the girder depth is becoming large and impacting the foundations. Therefore, we are adding some stay cables to help reduce the effect of the vertical load to the foundation. That is a concept of the Extradosed bridge. So stay cables support some of the dead load, which is, I think it's about the 20 to 30% load is carried by the cables. And this Extradosed bridge developed in the original developed in France, but has advanced in Japan in many different forms. This is our bridge, 3-span continuous pre-stressed concrete bridge with a main span of 180 meter crossing over the river and 100 meter span for the side. So basically that both side span and the main span is balanced by its weight. Actually the world's longest Extradosed bridge is built in Japan in Kisogawa, which has 275 meters. Now, for the designing of the pile foundations, which also have a big foundations carrying the heavy loads, that bearing capacity was determined for each locations. That the end bearing as well as skin frictions. But majority of the load is carried by the end bearing. And the friction contribution is much less. Now, going back again, what is Extradosed bridge? Once again, as you know that the Extradosed bridge, cable-stayed bridge, box girder. So you have box girder bridge in this country. So box, as I said, that the box, if we adopt box girder bridge for this bridge, see the bottom, that the girder depth at the pier is going to about 12 meters. But by using the Extradosed bridge, that is reduced about half, 5.6 meter. But if you use cable-stayed solution, the depth could be about 2 meters. But for the cable-stayed bridge, you have a lot of expensive stay cables. So Extradosed bridge is something in between the two bridge. So before we design, that we did some design optimization. As I said, that how much load to be carried by the girders or how much load to be carried by the stay cable. It should be have some optimum. So we did some cost analysis. What is the optimum? So the total cost is, as shown in this equation, a function of stay cable, cost of stay cables, cost of girder, cost of pylon, cost of foundation. But in our project, the cost of pylon and foundation are not much impacted, so that we have done the analysis of how much stiffness given to the girder and how much stay cables to be used. So this is the curve that the vertical direction is a cost index, and the horizontal direction, that is a girder depth. At the center, near the optimum, and also the yellow line shows the cost for the stay cable, and the red one is the cost for the black one is the cost for the girder cost. So the total is the summation of those two, which comes up with the red line. So the bottom is the optimum cost. So the girder depth is about 3.3 meters. All the bridges that we designed this way, that optimizing the structures. Loads and loading combinations that I have already mentioned several things. So, but in addition to the usual load, we have to consider about the creep and shrinkage of concrete. And also we are considering the differential settlement, that in case that some foundations are settled. And we consider about 10 millimeters settlement relative to the other piers. Also, the deflection of the girder due to live load is also important, especially for the fatigue. As I mentioned, that the sudden loss or replacement of cable, as well as the replacement of bearing, is also considered. Temporary construction loads, stage construction, also considered in the design. So in the design, all these loads are combined with some factors. And in the design, that we have two limit states. One is ultimate limit state and service limit state. Ultimate limit state is primarily to determine the strength design, whereas the service limit state is to consider about the serviceability. So this is the structural modeling, that 3D finite element element model, and all the stay cables, girders are modeled as one single element, and also that the foundations are modeled, and the foundations are supported by the soil spring. The pre-stressing steel force due to the inner outer cables are also included in the model. Also, stage construction is also considered, but I would like to skip this. This is too much for that, so let's go to the next one. Now, for the stay cables, the alignment of the stay cable is very important. First, that there is on the right hand side, there is a three type of alignment of the cable: fan type, half type, radial. And the fan type is the cables are parallel to each other. Sorry, not parallel. Not parallel. Half is a parallel. And we use a fan type, which is normally used, which is more effective for the cable useness. So as you see on the middle picture, that the green cables and yellow orange color cable that are aligned like a fan type, and the cable's diameter depending on the forces to be applied. So on the left side, that you see that the cable is fixed to the pylons, and the pylon is inclined outwards, but this is purely for the aesthetical reason, not any structural reason. And the girders are sitting on the pylons by 4 bearings, and each support has a vertical reaction about 6,000 kilonewton. As I said, that the cables that you see the section underneath, that the cable is consistent of several strands, and the strands are encased by the polyethylene cable. But each strand on this one, that is, we call it coated epoxy filled concrete. So each strand, each wire is coated with epoxy, and the void between the wires are also filled by the epoxy. So there's no chance of water or moisture coming into this area, so the resistance to the corrosion is high. The stay cable anchorage is also one of the design issue. How to fix the stay cables into the cable pylons. We have adapted, the contractor proposed this type of system, that the saddle, we call it saddle, the bruised part is saddle, and both ends of the stays are fixed to the stay. So the tensions from the stay cables are transferred to the blue part of the saddle, and that the blue part of the saddle transfers the load to the concrete pylons by stud or direct bearing. So this is a saddle, and for each strand there's a saddle layer by layer. And the stay cables also has a the important to resist to the fatigue, because it's a number of loading due to the live load as well as wind. So in order to design the stay cables safe, we have limiting the stay cables stress level, so that actually any number of cycles would not affect the fatigue. So we call it endurance limit, and the stress due to the amplitude of the stress is limited to the 70 megapascal. Now we finished about the stays. Now we are going to talk about the main girder. Main girder is composed of 3 cells, as you see in the sections. The left-hand side of the section is at the pylons, so the girder depth is deeper, whereas at the mid-span, that the girder depth is reduced like a ordinary continuous bridge. So at the pylon, the depth is just 5.6 meter, but at the center, the depth is 3.3 meters. And also that the thickness of each bottom or the web all changing, because depending on the stress conditions. So right hand side shows how the thickness of the box girder differs. At the pylon location, that's where most that the bottom slab reaches about 800 millimeters thickness. Okay, now I have talked about the fixing of the cable to the pylon, but also the other end has to be fixed to the girder. So these stay cables are fixed to the girders, and as you see in the bottom picture, that the stay cables shown there. So there's a stay cables are hanging the main girders, that's creating some bending of the a positive bending. So in order to resist that tension due to this positive bending, that the pre-stressing cable is introduced. That at this stay cable locations, we have a yellow colored member that we call it the diaphragm or the bulkhead, that to keep the shape of the box girdle. How many minutes? Thank you. Okay. For the design, we have some factors that we have to consider, that especially the serviceability. Because the reinforced concrete is has crack, theoretically. So, but however, we have to minimize or limit the crack width. And in the BS 5400 standards, that gives a allowable or the permissible crack width, and we have used 0.25 millimeters width, which is allowable for the design. But for the pre-stressed concrete structure, as mentioned, for the girder, on the longitudinal girder, we use the class 2. I'm not sure you know that category, which is allowing some tension but the crack is not visible. So that is class 2. So for this class 2, that the permissible permissible concrete tension is defined as 2.55 megapascal for the concrete grade 50 concrete. So the design has to be made that the tensile stress is not exceeding 2.55. So the right hand side chart shows that the stress is, and the bottom dotted line shows the 2.55. So the all stress is above, which means in the compression side. So there's no issue of cracking theoretically. Maybe I will skip this one. As I mentioned that the girders in the longitudinal directions, we are introducing lots of pre-stressing steel because of the tension, to reduce the tension forces. This is at the top slab. You see the section there that the pre-stressing strand is embedded in the top slab like that. So for the bridge, in total 90 number of pre-stressing strand, which is made of 7 wire strands, is laid. In the same way, for the bottom slab, in the bottom, also the cables are laid. Now, the cable often have a vibration due to the wind or the rain and wind. Because that the stay cables are very low damping characteristics. So in the cable stayed bridge, Extradosed bridge, we consider that 2 vibrations which might be possible at the site. One is vortex induced vibration. In other words, that it is called the Kelanin vortex. And the another one is rain and wind induced vibration, that the combined effect of rain and wind. So once again, that the damping is very low. As I said, that this is a damping, logarithmic damping, slope of the damping that is very low as 0.01. So it is very easy to vibrate. So this is a famous Kelanin vortices, that the vortices when the circular cables, that the wind is acting, then the vortices coming in staggering way, and that when that vortices comes out with the same frequency with the structural natural frequency, then it has a resonance and vibrate. So that is a Kelanin vortices, and it often happens in a very low wind speed, like 5 to 10 meters even. But this is a very small amplitude and may not be a big issue for the safety. But for the rain and wind-induced vibration, this is when the rain is falling onto the cable, then there is some water flows along the cable. We call it rivulet here. This and this, some kind of that, and when the wind is acting, unlike the circular, theoretically circular, that will make the section very unstable and create an amplitude as high as 2 or 3 times the diameter. So it's quite a very dangerous vibrations, and we have to prevent this. However, I think our bridge is not as long, so may not be an issue. But as a precaution, that we are going to study about vibration. And usually there are 3 methods to countermeasure the vibrations. First is changing the surface characteristics of the cable. So there's no such uniform vortices or something like that. So often use a helical on top of the cable or some dimple, roughness. The another one is giving some damping by installing damper. The third one is increase the stiffness of cable to raise the natural frequency, so there's no such range that the wind is even that ordinary wind is no, I'm sorry, if the stiffness of the cable is higher, then the wind to vibrate is much higher, so it might be, we can avoid that vibration. So however, for this our bridge, that we are going to install mechanical damper, that is damper here. So it's like a stake, and there is a damping, oil damper. So when something vibrates, that piston is moving up and down and absorbs the energy. And in addition, that we are going to have some helical surface on the cables. So at the end of the project, the completion of the project, we'll check that vibration as well as wind, rain, and find out what. But we're going to install some of the cables from the beginning. Pylons. Pylons is basically designed for the compression force from all the cables as shown there. All the forces from the cables are coming into the pylons as a vertical load. Also, the bending is occur due to the difference of the cable in the left hand side and right hand. So basically, that the column is designed for the bending and the compression. So this is it. Foundation of the pylon. I'm just tell that the pylon foundation is supported by the 2 meter diameter cast institute board pile. And this, I think, a 2 meter diameter pile might be used for the first time in this country for the structure. And the pile cap, and the number of piles is 30. 5×? 네? 35? 35, yeah. 35 piles are supporting each pylon, and the pile cap, which transmits the load, has a depth of 4 meter maximum. Okay, now I finished the design of the Extradosed bridge. So now I am going to the totally different topics. Okay, we have soft ground in our project area. I think you're familiar with the country's soft ground. As I said, the peat and the clay soils existing in the ground and need to be improved. So in our project, there are 3 areas that we needed to improve. First is embankment at merging point at CKE, that we are now doing the improvement by paper drain or band drain with use of geotextiles. Second one is a retaining wall and culvert. We have a retaining wall and culverts, and because of the time constraint, we are going to use a pile embankment, means dripping the small precast concrete. And the third one that I'm going to talk today is a bypass embankment at CKE and bypass for the CKE end sections. We have adapted cement mix treatment. So I'm going to talk about this bypass. So the yellow is really end point of the CKE end, and the left side is Kelanin River. So yellow is existing CKE expressway, and in order to construct our bridge, that we need we are constructing the bypass, which is colored as red colored, and the embankment. This bypass is to carry 4 lanes, and each lane width is 3.1 meter. And see, the embankment depth is 2.5 to 5 meters over the existing soil condition, and peat has a 4 meter and clay is 5 meter. Those 2, peat and clay, is subject to the consolidations or the settlement. So for usually that when we design for the embankment, we have two criteria. One is settlement, another one is stability. And settlement has like this. I think you might know that the Extradosed settlement is less than 150 millimeters, 3 years. But in addition, stability, slope stability, circular phase stability, has to have a sufficient safety. And for the short term, 1.2, and long-term basis, 1.25. Soil has to be investigated before the design. This area is very soft soil. We did some 12 boreholes over the 1 meter length, and we found that the peat organic clay exists at the depth about 10 meters, and the N value by the standard penetration is almost 0. Moisture content is as high as 276%, so it's like a water-like layer. So before we determine the cement mix soil improvement plan, we have studied several methods. But the point to determine is that we have to have a confidence of the reliability, but at the same time, this bypass construction is introduced after the contract is made. So the contractor wishes to make it not to affect the entire construction. So the short construction period is highest priority in addition to the cost. So as you know that there are a number of soft-grained treatment methods like band drain, sand drain, and pylon embankment, deep cement mixing. But we thought that there should be another method which could be better. For example, the band drain, sand drain requires 9 months only for the consolidation, overloading, preloading. So this cannot be applicable. And pylon embankment, which is driven into the soft soil, also costly. So therefore we proposed, the contractor proposed the cement mix, and which is a cement mix method, which is a reliable and rapid construction and economical. So for determining the soil improvement, this is the right-hand side is a schematic drawing of column, improved cement soil mix cement column, laid like this. The column is made of 1 meter, 2 meters which is built into the soft ground, and the spacing of the column is determined depending on the soil conditions and the loading conditions. So with all this, depending on the embankment height, but anyway, we have the required strength was determined like this one, and depending on the locations. So for each locations, we determine the layout of the column. Where the soil is strength, you may not need much columns. So we have 3 cases. Case 1 is 40%, AP is 40%, and the case 3 is 33%. Case 2 is 50%, which means more densely. So this is also a part of optimizations. So depending on the geotechnical condition as well as surcharge load, we have determined these 3 types. And before we do that, how to determine the design, means cement, amount of cement, and also water cement ratio, and what else? Cement ratio. We have to do some testing, laboratory testing. We took the soil from the actual site and do the manual rotary mixing machines at the laboratory. And we tested for the improved soil by compression test, like for the 7-day or 28 days. So these are the failure. This left-hand side is a mixture of the soil manually, and the right-hand side is a failure of the soil column. So with this, we had a very good strength, but we found out later that mixing by this manual, rotary machine, is not representing the mixing at the site, which is not like this one. I will show you later. So we have done that test, but we bring the the actual power blender machine at the site and take the sample and found out that the strength cannot be obtained as much as we expect. And we found that it is because that rotating about 10 meters of soil uniformly is not achieved by the water cement ratio of 100%. So we increase that more waters to make the soils and cement more fluidity, and also because when you have more waters, that reduces strength, right? So we have to adjust the cement ratio. So we did such a lot of exercise, and finally we got a good solution. This is a power blender. I will show you that how it works. So this is a trencher that there is about 10 meters that is rotating and circulating, and at the center, at the tip of that trencher, there is a cement mix penetrating into the soil. So this rotating and mixing vertically and making the uniform soil cement column. So this is but you see, for mixing uniformly for the depth of the 2 meter is not as easy. So okay, let me stop here. So anyway, that we have changed several trial and error, and we changed the water cement ratio 135%. And then, as you see that column, that finally we got the strength of this much, and whereas the requirement is much lower. And also that you see that these 3 columns indicate that the depth of the soil, 1 meter, 4 meter, 8 meter. So in the different soil depths, the strength we obtain is very similar, which means uniformly mixed for the entire depth. So after we have done this operation, we checked that what is the actual strength of the improved soil. That is done by the standard penetration test at the site. So we have done for each 3 locations, we did that. And there is an equation to convert the N value to the uniaxial compression test, as that equations. So that gives, and we proved that the strength is sufficient, much higher than we expected. Now we are talking about some settlement issues. I would like to quickly go through that. Settlement is also to be estimated, but if we do not have any soil improvement, we expect that the settlement is as much as 1.5 meters. So, however, we are doing some this stabilizations, and these are the calculation after the improvement. So I'm not going through detail, and there is a good concept that how the stress is shared by the column improved and the soil not improved in between. So that we have a concept of stress sharing ratio, and usually that value is like a 20% or 30%, which means if the column support and total settlement is estimated like this, it is like 20 to 20 centimeter, 11 centimeter, depending on the site. So that is a settlement expected. I will talk about the actual settlement at the site. Also, the slope stability of the embankment is done. So originally, the soil without improvement is very low value of the cohesion, but after improvement of the soil, the column, that the C value is getting much higher, about 10 times. So this will be used for the analysis, and the soil is improved. We also use a geotextile to transfer the load from the embankment to the bottom of the columns. So the safety is about 2 to 2.4, which satisfies the design conditions. Monitoring was done at the 12 points for the settlements, and also horizontal settlement was measured. And the actual settlement from the start of the embankment until the end of the pavement is merely 63 meters, which is much smaller than the expectations. And after the, this bypass is already open to traffic, and there's no settlement since that opening. So this is a laying out of the geotextile after the completed soil improvement. This will take the tensions and transfer the vertical load uniformly to the improved soil. This is compaction. This is and this is the completed stage. And I think some of you will already use this bypass. How many more minutes? Okay. Temperature control of mass concrete. Now another different, totally different topics. Because this Extradosed bridge is a massive structures, we are very concerned about the cracking due to the hydration of the concrete. And here we have two items, the pile cap and pile base. And for the pile cap, we have used the grade 40 concrete, and we are going to explain to you that we have several layers of casting, not the casting all at once. And the second one, pylon base. I don't think I will explain this because of the time. We have used partially for the pipe cooling. This is a concrete of grade 50. Now, why we need to control the temperature? It is to prevent the cracking, thermal cracking. One is we have to control the maximum temperature which occur at the core of the structure. And another one is temperature difference, which means the temperature difference at the surface and the core, which creates some cracking. Now for the maximum temperature, it is said that about 75 degrees, the maximum temperature should be less than this 75 degrees. And this is to prevent the delayed Ettlinger formation, DF. This cracking, I'm not sure that you know that this is the very chemical actions when the alkali or C3A or SO4 contains cement is used, and the temperature is as high when they are casting, and when the water is added after the concrete is hardened, that the Ettlinger is expanding and cracking, and this cracking is very dangerous because the crack may appear not immediately after the casting, but after a few years, sometimes 10 years. So this is very important criteria that we need to strictly follow. The second one is temperature difference. If the temperature difference between some locations, then there is some tensions and develops the cracking. So we control the temperature, 20 degrees difference between. But however, this cracking is only occur after after few days casting, after few days after casting, because the temperature difference will be diminished after few days. So this is well easy, not much difficult to control. So this is a DEF tracking, and this is the photos taken by Professor Nanayakara, and so that the lesson we have learned, still DEF is not fully understood, but the maximum temperature should be limited to some degree, in this case 75. And also cement has to be reduced, SO3 or the C3A. But this is very difficult. Also supply of water, if the water is continuously applying after the concrete, then it will expand that trigger and develop the cracking like shown. Some of the crack is like as see that a few millimeters width and not acceptable as a structure. So this is very important phenomena that we have to avoid such cracking. Now, I'm a little bit confusing you, but according to the permissible cracking that in reinforced concrete, as I already mentioned, that the cracking, allowable cracking width is determined by the British standard, and for the severe environmental condition, it is defined as 0.25. But for very severe, like seawater spray, that is only applicable to the structure built adjacent to sea, is 0.515. Of course, obviously, that more susceptible to the chlorine in the airborne, then that the crack width is to be reduced. But in addition, that in the design we have a sufficient depth of the cover. Cover means depth between the rebar and the concrete surface is determined like this, which is much higher than normal structural design. So in order to control the temperature, what we have to do is first a selection of material and the mix design. And the fly ash, which is very helpful to reduce the temperature, that fly ash contained cement is very useful. And cooling the concrete, fresh concrete, that is made by the cooling the fresh concrete itself by adding some ice into the mixing water, or cooling the water circulating into the mass concrete. And also curing method is very important. And in addition, the interval of casting between the layers is also a parameter to control the temperature. So after selection of the material and mix design, the mock-up test is to be done, and the temperature measurement for the mock-up specimen is to be done. And thirdly, with that result, we are going the finite element heat analysis is done for the actual structure. And with that, the temperature concrete is cast for the pile cap, and the temperature measurement was at the site. And finally, after the casting, that as I mentioned, that the concrete surface should be checked whether there is any harmful cracking, especially for the thermal cracking between due to the temperature difference. So mock-up test and analysis, temperature, all these are done. So again, this is the pile cap dimensions. As I said, that the width 20 meter, length 28 meter, and depth is 4 meter. The concrete volume is 2,135 cubic meters. So this is a mock-up specimen for the 2 meter, and the three sides colored by gray. It is not insulated, and the right hand blue is the normal formwork. I'm not to explain why this is so, but this is how to make the specimen. And the depth is 2 meters. The concrete is mixed design is shown here. As I said, that the cement has 25% fly ash contained PPC cement. And the aggregate also important for the expansion of the expansion, and we have used the granite. Now for the concrete used for the fresh concrete, see that table, that the plant, we have a batching plant which is 2-3 kilometers from the site. So when the concrete temperature is at the 1 and 2, 90 degrees or 16.5 degrees, by use of a lot of ice chilled waters. But at the site, the temperature rises only 0.5 or 1 degrees, because so close to that. We have considered that the temperature fresh concrete temperature is to be around 25 degrees, but on this we have even lower temperature. This is a mock-up specimen. This is how that mock-up is, and some couplers wires are installed. And this is how the concrete is casting and the formwork concrete. And this is curing conditions. The side is made of plywood. This is a temperature history of the mock-up. There are a number of locations, but of course the center core is the highest temperature. In this case, the temperature is only reaching about 65 degrees or so, far less than the maximum temperature of 75. But for the temperature difference in this specimen, that it is 2 locations that exceeding the requirement of the 20 degrees. We observed that during the curing that the contractor sprayed the cold water that makes the surface cold, so that the temperature difference becomes larger. And we consult with the professor, and we stopped that spraying the cold water on top of the surface is not useful, because it makes more higher temperature difference. So we have studied that from this that controlling the temperature of the fresh concrete to be cast at the site is very important, and 25 degrees, then we can probably successfully also at the actual construction. And the temperature difference, we have to have a more careful consideration of the curing. This is a sample analysis for the actual pile cap. From these mock-up, we have all the data are taken and adapted the key parameters used into this analysis. This is a 1/4 of the model and the 3D analysis. From this analysis, we have considered the 2 options. One is casting 2 layers. The another one is 5 layers. 2 layer means casting the concrete about 1,000 cubic meters per month, and the depth of the casting depth is 2 meters. Whereas the right hand side is 5 layer, which is 0.8 meters, but have 5 layers. The important thing that we want to stress is that in case of the left hand side 2 layer casting, the casting is to be done not only night time but at the daytime. That means the concrete is going to be temperature is going to be raised during the casting. But because that the temperature, lowering the temperature, casting temperature is most important, we consider that it is better to cast the concrete only at night time, which means within 8 hours. So we reduce the number of concrete to be cast all at once, about 400 cubic meters. So these 2 comparisons are theoretically done. So as I said that 2 layers case, first layer is cast, and after 3 days, second layers. And for the 5 layers, you have more time required. First layer, 3 days after, second, 4 days after, those elapsed time, the casting interval, is determined that the temperature is lowering after a few days, so that the total accumulation of the temperature is not that much high. This is an analysis result. The red is usually not in good conditions, higher temperature. Green or the blue is low temperature. And the left hand side, that for the analysis, the temperature is 74 degrees, which is almost close to the 75 degrees. But whereas 5 layers, the temperature is only 63 degrees, much lower than that. That means more allowance to the temperatures. So this is a history diagram of the temperature. The left-hand side, you can see the two top, first layer and second layer, which is going close to the 72 degrees. So the first layer is cast, and after 3 or 4 days, that the first layer concrete temperature is lower down. Then the second one is added, and that gives us heat to the first layer. So in the same way, 5 layers, you can see interesting curves that first layer is going down, and second one is added, then it's going up. And then finally, few days later, 10 days or 20 days later, the entire concrete temperature is lowering low. So this is something accumulation of the heat, interaction of the heat between the layers. So this is what the actual number of temperature for the second layer, for the 2 layers options, that it is more than the temperature difference is 35. That is more than higher than that's not satisfy the requirement. But for the 5 layer case, maximum temperature is 61, which is lower than the 75, and 90, so which is lower than the 20. Both satisfy the requirement. So this is also the case that, and after that, we have studied about the crack index. That is, when the temperature changes, that there is some there is a tension stresses due to the temperature differences, and so this studied about the cracking index, and the 5 layer case has no theoretical cracking, but whereas second layer case there might be some cracking. For the 5 layer case, because that the multi layers, you have to have some green cutting, and usually that is done by the water jet, high pressure water jet, but it is very costly. It takes time, and the treatment of the water is not as easy. So that we have the contractor proposed the use of the some bonding agent between the concrete, which is not doing the removing the latence, but some adhesive, some liquid to be laid over the first layer, and that foam suppress the breathing and mix with that and make a very hard layer of the polymer. So this is used for this project. So in order to do that, to improve that this joint would not be a weak point, we have done 3 tests. One is no treatment, which means no treatment, just casting the concrete. The bottom concrete square rectangular, cubic, cubic. That is a base, and on top of that there's 4 circular ones. So the bonding is between the circular cylinder and the bottom base. And the left one is no treatment. Second one is green cut, high water pressure, type B. Type C is a bonding agent. And from that, we found out that there's no, these are the strengths. There's not much difference with the bonding agent is good adhesion, no problem with from the usual water jetting. This is a way that this is actual construction site. This white color, that is a bonding agent. It's sprayed over the interface between the layers. Temperature monitoring point for the actual. We have several locations. For each layer, there's six measuring point, core and the surface. So total number of the measurement is quite big, and also, and this is the actual construction schedule. As I said, that the first layer casting and the 4 days are basically 4 days interval, and finish the concrete casting. And the concrete temperature, actually, we have casting for that is about 21, 22 degrees, less than the temperature, the target temperature of 24.5 degrees. So this is a curve that how the temperature changes. That the blue one is a core temperature, and the orange one is a temperature at surface. And the dotted line shows the difference of the two. So first, when the first concrete is cast, the temperature is dropped a few days later, and then this one second layer is cast, then you see that the temperature rises to this one. But for the third, it seems like it's not much impacted. So, but it's a very interesting curve that the temperature, accumulation of the temperature to each other. And I will show you same one, but I'm not, because of the time, I would like to go quickly. Same one for the second layer, third layer, fourth layer, fifth layer. Okay. So anyway, if I explain to you that this takes about 10 minutes. After the concrete is cast, this is the surface of the pile cap. This is the joint, and we see that there's no obvious cracking in the concrete. So I think that's all about my presentation. And for the summary, that new bridge in Sri Lanka, named the Extradosed Bridge, and steel bridges are under construction with the target completion schedule of December 2020. New technologies have been employed in material design and construction. And it is my view and recommended that Sri Lanka design standards, or the ICTAD specifications we are using for this construction as well. I think it is better to incorporate all the experiences and construction data we accumulated in this construction. And encouragement and incentive to engineer and contractor incorporate the new technology is very, very welcome. So all these are my summary. Now that's all about the technical. And now from here, that I will show you some of the photos that how much we have completed the structures. As I said, that it is almost 1 year and 2 months past. So the construction is rapidly in good progress. This shows that the blue part is the completed part. I mean, all the piles, not all, most of the piles are completed at the site, at the Orgadawata. This is also Ingurkade. Piling work still remains. This is at the Kelanin junction area. This is Kelanin end. And this is the Extradosed Bridge. This is the concrete for the pile cap, and now started casting for the bottom of the pylons. It's starting building up. This is the piles construction almost completed. Bypass is also completed. So this is the progress photos. That this is in the Orgadawata. That the both side of the carriageway is used, is now under construction, and lot of traffic diversion required to secure the working space. This is in the port access area, Ingurkade area, and the right hand side is a CB head CB bureau. The anchor frame installation work done by at night. This is an aerial view of MVP 10 to P14. This side is start forming for the construction of the beam. These are also the construction at the site. This is you see that pylons are still CB pylons. That is a new pylons after it, and built by the CB. And this is see the construction area. This foundation, this is the pylon foundation, very close to the river. And also you can see some concrete piers already built up. This is same. And this is that one is a bypass. So and this is a concrete pier with a transverse beam, pre-stressed, post-tensioned. This is a steel pier, which is now which is fabricated in Japan, and this is total weight is 260 tons. So each segment is like each segment 30 to 50 tons is disassembled and transported to Colombo. This is a girder for the Ingolkade on-ramp. This is a trapezoidal girder which has a length of about 165 meters, are pre-assembled at the shop. And the dimensions as well as the camber, all these are measured, and final inspection was made at the shop. This is a bearing. This is, as I said, that the pot bearing, and the static loading test was done, vertical as well as horizontal. This is a complete view of by 3D. This is the Extradosed bridge. The cables are orange, yellow color. This is the junction area. This is from the existing road to look at the elevated structure. This is the Olgadawata junction interchange. And this is the Ingolkade IC. This is a night view of the Extradosed bridge. And I would like to thank especially for those people, not limited to those, Ms. Darushika Jayasekara of the RDA, and Mr. Sato, Mr. Suzuki, Mr. Teruya, who are now present here, and package 1 contractor, also Professor Yakara, and Dr. Asiri from NBRO. So that's all about that, and I would like to invite any questions, but I'm running this one. This is the area review taken at the end of February. So any questions? I think about 7. I don't think I needed to explain that it's
thank you very much. Thank you very much for your interesting and informative lecture about such a remarkable project which is currently in progress in Sri Lanka. To make this presentation more conversational, if you have any question, it is time to raise.
Based on the speed of construction, I don't decide to three box cutters, but if you do any construction, you will decide to take
What is that? Can't hear you. Still construction is faster or what is your question? Can you tell?
Question is whether speed was based solely on the speed of construction for box girders, or if you do a comparative study at university design stage, in concrete and steel, and what are the cost?
Well, that considering that heavy traffic congested area, one of the first consideration is to minimize the impact of the traffic, and so that the steel construction is much faster at the site, but the cost and also maybe fitting to the construction as such a area, because that also from the quick construction means the safety of the construction for the third parties. So all these that is very important, but I think you are interested in the cost, right? For the concrete, compared to the concrete. Concrete is, if that factor is just disregarded, concrete is cheaper. But you see that a lot of traffic divergence I didn't express. Already finished video? See that this is the package 1 area that needs to traffic diverge because the foundation area is also limited. So when we do the construction here, the traffic is moved to the other side and do the construction and then complete. Then we have to move in. And this also that if we have a concrete construction, that the pier is bigger, which means the size of the piers foundation is bigger. So that how much you include about that factors. But for this very congested area, if it is local area, surely I think steel will not be competitive. And but for the area that we are facing the traffic every day, even now, lot of difficulties actually. So also that the foundation is bigger, then also that may impact to the location of the foundation, which has so many limitations with the utilities. We are constructing the foundation only 60 centimeters away from the utilities, some parts. And that utility is not a tiny utility, it is 220 kV or 132, and if it's such a, I don't think that you cannot build, so there are two major utilities, and we have to build it in between. So even with the steel, lot of difficulties the foundation design, and if concrete is applied, I'm sure that it's going to be even harder, and I'm not sure what the solution would be. So anyway, that the utility lines are not in the carriage sidewalk, but also at the median. We have a CB cable as well as a 700-meter sewage pipe. So there's nowhere that you can design for that. So all this, it's not simple to say that only for the cost.
Can I ask a corrected question? From my saying that this specification, are these documents for future review and how you arrived at these important decisions, whether to go for steel?
Say it again, sorry.
Now you are explaining the justification for going for steel rather than concrete, which I agree. Just want to know whether they have been documented for future. If someone
For the maintenance you're talking about?
No, for say someone ask a similar question when you are
Why?
the documentation of these.
I think this is a
evolution
goal.
of volcages and all that.
This is goes through the before we do the detailed design. That time I involved. There is a feasibility study,
Yeah.
which is done cooperatively with the employer and the consultant, and also the bank, and finally decided this option is best fitted. So there is a report there. Yeah.
Yeah, those reports are still available.
Yeah.
The local.
Why? How we select the bridge type? It's there. It's there.
It is there and it's available for reference by say someone who wants to review.
I don't know. Review means what?
Review in the sense that say I'm not doing this directly. Say my business wants to look at how it does that. It's available.
I don't know where it is now because I came, but it should be there. Because there's no way that we can judge,
Maybe that's not and it does something.
There should be there. But I'm sure there should be.
We have developed a feasibility study, and feasibility study we have done, and we have done some reports on that. Why we are going for steel figures. That is actually congestion of the road, heavy traffic area, and also underground utilities and the limited space. Those are the factors that we are decided for the going for the street structures.
Thank you for your presentation. Participated in one of the presentations during years also. My question is technical. How do you tackle with that in the pylon foundation? So that you have completing this done in several stages. And if you consider that the shear transfer, how do you tackle with that shear transfer problem? And so that
You're talking about the shear force to the pile?
yeah, that's some several stage completing. That is not the monolithical completing.
Oh, you're talking about the pile cap.
Yeah.
Pile cap.
Pylon foundation.
Yeah. Pile cap.
Yeah,
No,
yeah.
you're talking about this one. This one?
Yeah. Pile cap.
This one.
Yeah. It has to be considered in the sense because how do you tackle with that particular case solution? And the second question is regarding the temperature of the mass concrete. I saw that for the Mohawk test, you have used some insulation technique right now. Insulation technique to maintain the temperature difference, I think. How do you maintain the actual on-site insulation technique for surface, right and bottom?
Well, first that the shear force. Well, that is a thick 4-meter pile cap that is supported by the 2-meter pylon. Board pile, spaced 3 meters distance. So it's like a very densely supported. So that the pile cap is like a rigid body. Although if you do it analysis, it's like a beam. So in the design, that of course that we are designing that pile cap as a beam, which means that there's a bending moment, and that creates a shear force. So that shear force is of course designed. Okay. and the startup is there, a design. For the construction joint, is that enough? And the second one is you're talking about the initial curing method.
Curing, but insulation has to be done to control the temperature difference.
You mean you're talking about the what?
Surface
Temperature control of the temperature difference.
temperature difference, yes.
Difference, how to control?
How do you check insulation?
Well, actually, that we have used plywood, plywood for the side formwork, and also that the layer by layer. So without casting all at once, the temperature is lowered, and adding that one, so it's that is also controlling the maximum temperature as well as the temperature difference. So for the curing after site is plywood, which is used most of the construction here.
At the bottom and top,
Bottom is casting on the ground, right? I mean after limed concrete, and the top is there is a blue sheet tent, but it is casting layer by layer. But actually, as you see that all the history of the temperature that is within the I think mock-up and also the theory analysis and the actual that complete study is made possible to achieve the two requirements, the maximum as well as the temperature difference.
My question is on solid column. For the solid column, can you please explain the construction steps? What is the first step? And there should be some method of the construction for the solid columns. Solid columns.
Number of soil columns or the density?
Construction method.
Soil column.
Yeah. Soil column.
I think I show that
Yeah, you show that.
this method.
That mixing machine.
This is tip of that protein. There is a cement grass is injecting. So this size is about 1 meter. This kind of. This is not one. It goes deep into the 10 meter depth and rotating and pulling up. Then the soil cement mixed column is there. So one is here and the one next column is here will be here. So it's made like that.
So it injecting to that little bar.
No. It's this furniture has at the tip. There's a jetting. The cement mixed solid. So when they rotating at the same time, that is nice.
They are feeding that.
No. That's the you mean that we have mixing equipment near the site? So when you rotating and mixing, so it's building up. So it's smooth, right?
Okay. Can I ask a question? You ask me. Can I ask a question, Doctor? Thank you very much for your brilliant presentation. And you're going into the details of different control and a lot of
things which are of interest to engineers. My question is simple question. What is the projected lifespan of this whole construction? And secondly, have you taken and what is the technology transfer to the people who will be maintaining it afterwards? Because some specialized materials are being used like polyester coatings on the spans for anti-corrosive properties, and these are the things which need to be maintained, I think, every now and then, and properties to the areas. So is there a technology transfer system from Japan to Sri Lanka, and the authority is going to take over the maintenance? The other thing is, since Japan is very familiar with tsunamis, some areas are very close to the sea. Has any design calculations done for any unforeseeable future tsunami or geological changes in the area? Thank you.
Well, first lifespan. Okay, there is a actual and theoretical. Theoretical means how the design treats the lifespan. That is based on the BS standard. Main structure is 120 years. Okay, it doesn't mean that you leave it and 120 years are survived. You understand, right? It's the purpose of determining the design life for is to determine the intensity of the loading. So as a probability theory, you know that the longer the design life, the more higher intensity to be used for the design. That is a design life. Okay? But it doesn't mean that it is safe for 120 years without maintenance. It is not. For the maintenance purpose, that we have to do the maintenance. For initial stage, there may not be anything, but usually that for this kind of big bridge, they initially 5-10 years, but when it becomes like let's say it's harder to say, but it's depending on your interest. That if it is grading 20 years or 30 years, the interval should be shortened to like every 2 years for the detailed inspection. But for the, but at the same time, like other road structures, that the inspector has to travel the structures and by the car or looking at, not measuring anything, but see any anomalies. It is usually the beginning that maintenance mostly required is the pavement or the drainage. But the major structures, I don't believe it will come soon. And the paint system, as I said, that is very good painting, unless something scratched or somebody damaged intentionally or something. According to my knowledge, that the painting could be more than 35 years general. So after that, you have to repaint. The concrete is also very durable. Unless there's some cracking, it should survive. But for the stay cables, that is a key element of that one. I do not think it is going to be wrong, but we have to check if there's any loosening or something by the visual inspections or touching. You see that any anomalies. Now, with regard to maintenance, and is going to maintenance manual to be provided by us at the end of the construction, at the completion. How frequency, what to see, and what to do. So technology transfer, yes, it is included in our scope of the work as a consultant. So that we have done, the technology transfer means lecturing or working together with Sri Lankan people in the consultant office. Also that the contractor is working with subcontractors, which means also contractors of the Sri Lankan. So through those experience that the technology or the engineering know-how is transferred, and at the same time we have had the seminars, educating purpose, inviting professors or some people outside. We do that. But the most important thing is not the giving, but the the people who wants to learn has to learn. Tsunami or I don't know. I'm not a geologist or anything, but how can we estimate that the 10 meters tsunami coming into this bridge site? But in the tsunami you have in the Indonesian earthquake, it's not like 1 meter, or I don't know much about this. If it is 1 meter or 2 meters, I don't think it will damage to our structures. Entirely safe. But if it is 10 meters like in our Tohoku area, it may be the bridge is entirely covered with seawater. I hope it's not happening. I don't think it happens. So that's all I can.
Thank you for your valuable presentation. I have one question that not only related to this project. When we are implementing this type of infrastructure project, the great problem which is coming to our mind is how to divert utilities and how to identify the utilities underground. So, what is your opinion regarding this identification of utility lines which are not included in the maps? So, how you are identifying? Only on trials, or do you have any other technologies using in the map?
I think Sri Lanka is a very advanced country in terms of embedding the utility into the ground. In many countries, in the Asian countries, utilities are above the ground. You see that the Thailand or Vietnam, bunch of the. So your country is very advanced, and Japan is also now embedding the utilities into the concrete, But the problem here is you don't know where the utilities and where, not accurate. Who knows? And there's a main line as well as small lines here and there. So it's not like easy. So during the detailed design that I proposed, RDA CAM shifting the utility, bunch of utility lines into the common box like we have started right now doing, then we can freely install the piers. But RDA said, don't think about that, it takes another 10 years to do that. So we gave up. So that means our pier location is all changing depending on our survey during the detailed design time. But detailed design is only 10 months. What we can do for the investigation of the utility is spot checking. That's not enough. That was not enough. We thought that's enough. So after the construction start, the contractor is doing entirely for the construction area. But even that, there are many minor ones here and there. So I don't know if there's any good technologies to scan the entire utility map. But there are some technologies like magnetic field, but I'm not sure that how it can be really actually. So the best way is even now digging by manual and see that. So it's a low technology.
Thank you.
Finish?
Yeah, due to time constraint, let me end up this Q&A session. So from that, I cordially invite Professor Ranjit Disanayake, Chairman of Civil Engineering Sectional Committee, to deliver the token of appreciation. Thank you, sir. Now it's time to give the appreciation to the hard work behind this event. Vote of thanks. Team leader of new bridge construction over the Kelanin Bridge project, Dr. Harugaz Mahashi. Chairman of the Civil Engineering Sectional Committee, Professor Ranjit Disanayake. Past President of ISL, members of the committee, members of Institute ISL, and ladies and gentlemen. It is my privilege and greatest joy to extend a vote of thanks to all those who have contributed to one way or another to make today's public lecture a resounding success. Dr. Harukazu Hashi, we are humbled by your kind gesture in accepting to give this public lecture, having a valuable time taken off your many responsibilities. I thank you with a deep sense of honor, privilege for sharing the advanced technologies involved in the construction of new bridge over Kelanin River and design of the Extradosed bridge with us today. Getting to know the engineering challenges in design and construction of this national project was very much valuable for all of my fellow engineers and other participants. So, Dr. Hashi, I thank you again. May I also thank the Chairman of Civil Engineering Sectional Committee, Professor Anjit Sanaka, whose guidance, concern, motivation and immense support paved the way for the success of this event. Your arrival with unconventional thinking that shape up the civil engineering field for a better future. All the past presidents of IESL, sectional committee members, thank you for your involvement and joining the lecture despite your busy schedules. I thank Ministry of Highways and Road Development and Petroleum Resources Development and also Road Development Authority for giving the consent to do this lecture based on their biggest ongoing project, which is undoubtedly a landmark structure in Sri Lanka, and for your kind presence here. My thank also goes to IESL for providing us conducive environment and facilitating us with refreshment to making these couple of hours comfortable for lecture. My humble gratitude goes to participants for coming today, and I believe you gain much more important facts from this lecture today. Last but not least, I thank my colleagues, friends and those who are not mentioned by names for your cordial cooperation, your work behind the screen to ensure that this occasion becomes a memorable success. As a Civil Engineer Sectional Committee, let's continue with the good work always. Thank you and good night.